Hello everyone. The next question we are going to take is combination sum 2. Okay. So we already have completed combination sum 1 and link will be in description. Let's do our combination sum 2. So the question is given a collection of candidates. Okay, given a collection of candidates, candidate numbers and a target number. So we have candidate numbers and there is a target. Find all unique combination of candidates where the candidate numbers come to target, okay, and the candidates may only be used only once in the combination. So, and it does not come, okay, the set must not contain duplicate combinations. And here one more thing is 1 and 1, these are present in here. So, but while in combination sum, it is guaranteed that the unique, okay, no, it was something like that. Yeah, distinct integers are used for as a candidate number, but here we can have duplicates. So we have to plan it, we have to code it accordingly. So let's try to write our function. It will be same as the previous one. So it will be define our helper function, and we are at ith in. Oh, before that, let's sort our candidate array. This will help us. Candidates, define helper, and we are passing the target and the ith index we are on. So here we are gonna write our recursive relation, recursive part. Now, if not if we are gonna call our recursive function on I comma a. Let's see. What we have to do is we have to find when target is equal to 0, we are gonna store our result inside a set. Okay. So if yeah, so we are going to call our helper function on helper comma on I itself, no, on I plus 1, and we will, if we are going to use our array of I mean candidates I, that taking 1 as a number, then we have to subtract the target minus array of I. Okay. Or if we are not going to use it, then we can simply call it on I plus 1 and only target. Now these are the recursive calls. Now the next thing we have to consider is the base case. So our base case will be if I is equal to length of candidates, candidates, okay, then return, or else, or if target is less than 0, then also return, because we don't need target less than 0, we need target is equal to 0, such that after subtracting all the considered indices, it will become 0. And if target is equal to 0, okay, then also return, but this time uh, result dot append, result dot add tuple of candidates, not candidates, we have to take also consideration, we have to take consideration all the indices, result indices. Okay. So if we are considering array of I, we are going to append it result indices dot copy plus pass ith to it, okay, else simply pass result indices. Yeah, else if it is not the case, then simply pass our result indices. Okay, and yeah, it should work. And add tuple of uh, candidates, of I, not I, let's use another variable, idx, for IDX in these indices. So yeah, and at the end it is sorted, so it is already, the answer would be also sorted. Finally, let's call our helper function and let's give our I is equal to what? Okay, let's give our I is equal to 0. Target will be same as target, and result indices, let's put it as empty in at the initial stage. Okay, cool. Now what we will do? Also pass result indices dot copy here. It doesn't matter, still we have to copy, and then let's return our list of res. Let's see whether it is working or not, or and debug our code. The array is not defined. Yeah, we have to use candidates. So this is first time I used array here. Okay, cool. Everything is fine. Let's see whether it will work or not. Yeah, it is working. Let's submit it. As you see, I have submitted it already and it was saying TLE. And it should again be TLE. I tried like 20 to 25 minutes on solving this question, but it was TLE. Yeah, TLE. Here it is TLE. So why it is TLE? Because it will go for 2 to 27 times for each of the index, whether we are considering it or not. So this approach, what I was going to show you through this video, that this approach might have worked for combination sum because all the integers were distinct, but this is not gonna work here. So what is the main crucial thing that we are missing? Let's see. Yeah. So this is 1 1 1 dot 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 1. Okay. So what we have to do, that if we have arrived at any 1, okay, here we have 1. Now we are gonna loop through whole this array. I've already gone through it, so I know this part. I have to do like this. I might have done like using for loop, but I'm used to do recursion, so I didn't thought of using for loop. But when I go through discussion section, then I found that using for loop is the best option here. Like if you want to do the same with recursion, it will become so ugly, like too ugly to deal with. So let's do it like this. We have our first index as 1. Now we are gonna check for other indices. So here we went to 1 and found that this is same as this. Okay, array of I is same as array of I minus 1. So let's continue. Let's go to the next index and try to go like this. Okay, so how are we going to consider this? To consider this will be considered when the recursion will be called on this part. Okay, like there is a first recursion. Okay? This is the first recursive function, and then for each I to n we are calling recursion. Okay, but here this is already done here through this way. Okay, this is like a tree recursion now, but here it is like a DFS call. We did it on 0, then we go for 1 and 1 again. Then here it is going like this fashion. Okay, but here it will first def search and do something like this, but the same thing I'm gonna do through for loop. Okay, and it will make us help, like whenever I found that this and this are same, then leave it, we are gonna deal with directly. I haven't seen the code, I saw the hint, so let's code it now. Okay, so to code it, what are the changes that we have to do? This will be same. If target is equal to 0, then yeah, we don't need to add tuple in it, because it will already give me the real solution. Like here we can also opt out of tuple if we have sorted the array, because it is gonna give me always uh, it might give me. Okay, let's see. Let's add, let's append it instead of a set. Let's try doing this. But I don't think that it will work, but let's try to see whether it will work. It won't work because if I am at array I, if I am taking I plus 1, okay, yeah, it will contain duplicates. It is going to contain duplicates. Return, okay, remove this list also, return res. Mm, invalid syntax from collections. Okay. It worked here, but let's submit it. Oh, it got submitted. So yeah, if there's no duplicate, it is going for directly, it will likely append this all. Okay. And if we have done I is equal to I minus 1 or something like this, okay, let's remove this tuple and let's directly, yeah, let's remove this tuple also and then try to submit it. Um, yeah, it got increased. And if we remove str of I and directly put a result indices plus dot copy plus dot dot, then it will become more better. Okay. Okay, let's now go to our combination sum part 2. So here we have to remove the DLE. For that, we are gonna call our functions differently. So how are we gonna call it? Let's remove this part. If I is equal to length of candidates, or yeah, then return. And now what we will do, we are gonna use a for loop as we described in here. Okay, this one. So 12 minutes. So for I in, no, for not for I, for next in uh, range. Next is not a good keyword here. NXT I will use for next in range. I plus 1. Uh, should we use I or I plus 1? If, yeah, let's go for I. And we are gonna also use this time an array because we are, this time there's no duplicate now. So let's use set first, then we will convert it into array. Okay, for next in range I comma length of candidates. It's okay. If so, what we are doing is we are considering I and we are checking for next, or rather for each I I'm checking all the possible. Okay, 1 second. So if I have I is equal to length of okay, then our target is less than 0, return. Let's do this. Or what we will do, we are starting from here. We will go check all these ones, and if array of I minus, if this is not, if this is happening, for this we checked all combinations including this and by excluding this. Okay. Here what we are doing is including this, including 1. If including 1 and doing all possible solution here will work, then go, then okay, return it, or do the same thing on 1, including 1, and yeah, this will work. So for next in range I plus 1, we have to do I plus 1 in here, I plus 1. Okay. if if I, okay, what if I is equal to 0? If I is equal to 0, if I is equal to 0, or instead I should say if I is not equal to 0 and or next, it should be next. Okay. If I, yeah, no, it should be I is the starting point. If I is not equal to 0 and candidates of candidates of next is equal to candidates of next minus 1. Yeah, will work. Next minus 1. Then just continue. I'm not gonna loop. I'm not gonna use our recursion on it. Else, call the recursive function on I plus 1. Okay, and also decrease the current value, like target minus candidates of I. Candidates of I. And yeah, and also we have to, okay, candidates I, target, and res index. We have to update our res indices copy. Okay, res indices plus I, because we have already taken it, and whenever we reach like target is equal to 0, we are gonna add it. Okay, it should work. 0 comma target comma. Let's check it. Control list indices must be, and okay, what's the problem? If I is equal, a second, list indices must be integer, not slices. Oh, and if I is not equal to 0 and candidates from next is equal to minus 1. Okay, sorry, next, not nxt. Now it will work, or give us some error. Okay, it worked. Oh, output is nothing. I'm not sure whether it worked or not. So let's try it on another input. Okay, this time it might work. Wrong answer. It is always returning nothing. Like if target is never 0. Okay, continue. Okay, it got continued, I guess. I is not equal to 0 and candidates of next. There might be some problem in here. Like if candidate of next, we have to start from I guess. Yeah, because we are gonna also include our I can target my candidates of I, and then we are gonna call it on helper of I plus 1. Okay, let's see. Not working. 0 comma target, and target is equal to 0, add it and return. Length of candidates or target is less than 0, return. If next, for next in range I comma length of candidates, if I is not equal to 0, then continue. I continued on it, and target minus candidates of I is done. A, it is sorted. Hmm, A, helper of I plus 1. Let's see. Candidates dot sort is set Couple of candidates of IDX for IDX in res indices, and I have added res indices plus I. Let's take our let's try it now for our input. Um, we have 10 and 1 2 7 6 1 5. Now as we have 10 1 2 7 6 5, let's sort it. 1 2 5 6 7 and 10. So whether, but it is every time taking candidates of I. Okay. Oh, I messaged, like we don't have to change our whole function. We should call it on I plus 1, and also whether take whether take ith value or not take it. We have to do the same thing, but it could be done in a single loop because I'm already, there's some problem, like I'm missing something. It won't work. I'm just running it. Ah, yeah, it worked. I don't know how it worked, but okay. I'm calling it every time, and that's why it worked. But still, it won't work because putting this outside will work better. Yeah, I'm not. Where am I using next? Oh, instead of using next, I used I. What I have to do is I have to use next now. If I is not equal to 0, and yeah, and do it on next. Next. So what we are doing here, we are calling it on next. Okay. Next is starting from I plus 1. We start from I, then we have to use. Okay, let's try this now. Yeah, here it will be I. No, we are using next, so we are going to add next. Or we are using I. We are not using I. We are for I. We are checking. Okay, so at first we go to I. We said that we are going to include I, no matter what. Okay, so let's do first target minus equal to array of I. I mean candidates of I. Target minus equal to yeah, candidates of I. Okay, and also res indices will be I initially. Now after that, what we did, we check whether target is 0, then append it. If I is like length of something, okay, so for this condition should be at first. Not, one second, one second. Mhm. Instead of it, let's convert our target comma target minus I, and then we are going to call it on next. Okay, next time we are finding. Okay, and this is, yeah, this should be but why am I starting from I plus 1? I should start from I. Output is 1 6 and 10, 7 and 10. If target is okay. Well, let's take an. start from length of nums I is greater than start and nums of I is equal to nums of I minus 1. Continue. If nums of I is greater than target, break, else call the combination sum on I plus 1 path plus nums of I target minus nums of next. Okay. And what we are doing here is next, if I is not equal to 0 and candidate next is on this, then do it on next and pass our next. We have to start from I. We are doing same thing. Uh, why is one so many times? Okay, I passed on next. So instead I should passed on next plus one. And yeah, I should have passed it on next plus one. This is really messy. I'm passing on. Okay, I should have passed on next plus one. Now let's pass on next plus one while 2 6 is there, 1 2 5 is there, 1 7 is there, 1 1 6 is not there. Because I have excluded that part. I is equal to 0. 1 second. If I is equal to length of kind or target is less than 0, then return. This time it should have worked. Okay. If I is not equal to 0, oh, if next is not, yeah, if next is not equal to 0, rather I should have used. Hmm? I am, I'm for every next, I'm going to, for I is equal to current to I less than candidate I plus plus. Okay. Path dot add. Here I have to add path size for candidate of I. Adding is done. Remove path dot size minus 1. Okay, this is the backtracking. This part is the backtracking. Yeah. Okay, let's start from first. 0 path risk. When target 0, I have already added here. This is done. If target is less than 0, then return. Okay. Or we are at the end of it, then also return. Else for int I is equal to current and I is less than candidate dot length. Okay. I plus plus. If I is greater than current and if I is greater than current and this is so instead of 0, we have to check for if next is greater than I and candidate of next is equal to next minus 1. Then we are gonna call it on next plus 1. Yeah, this was the problem and I should have debugged it myself. Let's submit it now. It got submitted. So the thing is, what we are doing, let's discuss it at last because it is, I mean, it is a messy question. You can do it simply with recursion, but while trying to do it this way, it will become a headache. So time 30 minutes. We can discuss for 5 to 10 minutes more. So what's happening? We have 1 2 5 6 7 10. Okay, we are, our I is initially at this, suppose. So and our next will traverse for all of these. This is our next pointer. So when next is, it will start from I also. If next is at I and we found that okay, if next is at I, we are gonna call it on next plus 1. It is going to call on next plus 1, and we have also used our next and we called on next plus 1. Okay, or what we do, res plus 1, yeah, we called it on a res plus 1, and we also appended this index. So for each of these next, for each of these next, we checked whether these both are equal or not. If these are equal, then go on. Okay, come here, okay, then go to next and decrease it like -6, do -6, and then continue. But when you are at this position, like you are at another I, okay, then there will be a time uh, when this candidates on next is called, we are taking one at first, but let us suppose we have 1 1 and 2. Okay, and let's do like 1 2 and 2, and we have to count 5. Okay, so we called our I, the I is here, and we called our recursion here. So we, what we see that here it is 1, here it is 2 and 2. So these both are equal, so we are not going to consider call each of them. Okay, if next minus 1 is equal to these, if next is at this place and these both are equal, suppose this is our array, then we don't have to separately call on both of these. Rather, what we can do, instead of using next, we can use I to call on it. Like when I will come here and we will check that next is greater than I. No, next is not greater than, next is itself I. So we are gonna take 2 into consideration, and 2 and 2 will be taken into consideration. Okay, so 2 plus 2 plus 1 will be taken into consideration. And it is, okay, it is going recursively. We have to think more on it to let to understand. So let's take our array again. 1 2, let's take our a better array. Okay, 1 2 2 6 6 6, yeah, something like this. So what what we are trying to do, we will first call our function on 1 and ask him that, okay, I'm gonna ask him that including you, find all the values that can be included to solve the question to get the target. Okay? Including you, including 1. Then when it will ask to 2, it is gonna say the same. Okay? Including 2, find all values next. And yeah, it is including every time, like candidate of next is included. And we are gonna do it on each index. So okay. So for one we did for all. Okay, whether include yourself and do the same. In A6 include yourself and do the same. But where's the choice of not including an element? You have to check it also. So if yeah, if next is greater than I, next plus 1, target minus candidates of next. So the main we are using DP, we have two choices, either include this or not. Okay, either include or not. So what we are trying to do is, let's call our first function 1. Okay, include this. Then what we will do, we will say that include 2 2. Okay, include 2 and then call on other. Else in inside for loop, this is a for loop, this interface is for loop. So we are telling include 2 then go for next, else include this 2 and go for next, then include this 6 and go for next, and leave it. Okay, so every call is saying to the next index, could be anywhere in the whole array, that include yourself and call the same function on other the rest of array. Okay, so this was our order of 2 and we are doing same previously, but this time the duplicates are there and we have sorted our array. Okay, so how are we going to use duplicates? Like if we are at 1, we said 2. Okay, instead of 2 we can say, okay, we let's suppose we are talking about 6. Okay, so if we are at 6, if our next is 6, we are checking whether this 2 and 6 are equal or not. So we found that candidates of next and next minus 1 is not equal, 2 and 6 is not equal, so then call it on 6 too. Okay, we called it not on 6 also. Now 6 will call it on 6 and this 6, but what it found that 6 is already there, so we don't need to call it, because if this 6 is going to call on this 6, instead of that the better part will be uh, this one is already has already, okay, yeah, this 6 can call on this 6, no problem. This one called on this 6, let's change the color. This one called on this 6. Now here this is a start, this is our I, so this can call on this and this can call on this, but what we removed here is, if we called on this 6, okay, then the same function should not be calling on this 6 and this 6 also. It will create like, it will create it into 2 to power n. Else we are making a series, like we are saying, rather this function calling on each function, you call this will call this will call this. This is the real crux of the whole question, and that's how you this is like included, I guess. Yeah, I have understood it. I somehow tried to understood it. Make like put some time on solving this question, same as me. You will get it. Okay, thank you guys. Subscribe for more questions. We'll meet you soon. Bye.